Assalamualaikum everyone, this is Juwairi Ahmed, roll number 2022 CE10 Computer Engineering student at UT Lahore. So today we will discuss the lecture 19 of CS 5150, uh, software testing, which it is all about dynamic analysis and testing part 2. So now let's have a look at its intro. The software testing ensures reliability, functionality, and readiness for real world use. Testing can be categorized by style, scope, size, and purpose. Challenges like flaky tests, which fail unpredictably, and brittle tests prone to breaking with minor code changes, highlight the importance of robust test design. Randomness in tests should be controlled with deterministic seeds for reproducibility. Test scope varies from small, efficient tests to large system-wide tests. Exploratory testing, though valuable for early investigation, relies heavily on tester judgment. Unit tests focus on specific functions or classes, while behavior-driven development (BDD) emphasizes user scenarios to align testing with real-world expectations. Now we will see this topic in detail. So we will start with the slides provided by the university. Here we have kind of test. Okay, so its intro I have already discussed in start. Uh, in software engineering, we categorize testing based on different criteria, including style, size, scope, and purpose. Each category plays a crucial role in identifying potential issues early and ensuring our system works as expected. Okay. Here we have style. Exploratory testing. Exploratory testing is when we manually test a system by navigating through it without a script, like walking through a newly built house without a guide, trying each door and window to check if everything feels right. Okay. Then we have smoke tests. Smoke tests quickly check if the main parts of a program work properly, like giving a car a quick startup to see if the engine runs before taking it for a drive. If it doesn't start, you know there is an issue to fix first. Um, black box testing, we test a program's features without looking at the code, just like testing a car's controls without checking the engine. Glass box testing, which is white box testing. Glass box testing involves looking into the code and testing it from the inside out, like a machine inspecting the engine and its parts for issues. Then we have yes, first testing feeds random data into the system to find unexpected errors, like pressing random keys on a keyboard to see if anything breaks. Then we have boundary value analysis. We test the programs limits by using values at the edge, like seeing if an app handles the smallest or largest numbers you enter. Dynamic analysis. Now, dynamic analysis tests how the software runs in a real time, observing its behavior, like checking a car's engine while it's running. Then we have scope. After exploring different testing styles, let's now look into the various scopes of testing. Unit tests, in which we have separate units, and we test each unit of the program. And we have integration testing. Integration tests, we check how different parts of the software work together, like making sure that kitchen lights and dishwasher can both run without tripping a circuit. Then we have end-to-end tests. In last, the end-to-end tests are those in simulate as which simulate a full user journey, like from selecting an item to completing payment. Then we have size of testing. If we talk about size of testing, we have three main types of testing: small tests, fast in process. Small tests run quickly on single functions, like pressing a single key on a keyboard to ensure its types. Then we have medium testing. Medium testings handle multiple parts interacting on the same device. Then we have large tests. Large tests cover different systems working together, like testing if a cloud server can support many users streaming a video at once. Then we have purpose. Regression tests, we will see first them. Regression tests make sure old bugs don't come back after changes. Acceptance tests ensure that in final state, if the product meets user expectations or not. Self test, we monitor the system's health to keep it running smoothly. It checks itself regularly and warns you if any issues need attention. Then we have flaky versus brittle tests. Flaky tests are tests that pass or fail inconsistently, often due to external factors or system issues rather than actual code problems. Non okay. Then we have non-deterministic failures. Like flaky tests often fail non-deterministically, meaning they fail randomly and unpredictably, like a light that flickers for no clear reason. Then we have yeah, now we have brittle testing. Okay, so the brittle tests usually check private parts of the code. Because of this, they are delicate and quick to fail if uh, if there is even a slight change in the details they depend on. Brittle tests might focus on very specific actions in the code instead of checking the overall result. This makes them unreliable and causes brittle tests to fail with even small unrelated updates. Aside random numbers. So now let's discuss the role of random numbers in a software testing. In most settings, random numbers should be deterministic, meaning they generate the same sequence each time they are used. This is important for reproducibility as it reduces test flakiness by allowing results to be consistently recreated. We have a global seed, which allows each part of the system to create a private random number generator by combining the seed with a unique identifier, so each component has controlled randomness. Okay, so we will just skip it. It is not a very important slide. Now, yes, we have test scope. Our next topic is about test scope, which refers to the range of code each test covers. Test scopes can be either small or large, each offering different advantages or and challenges. In small scope testing, each test covers a limited section of the code, focusing on specific isolated parts. This type of testing is efficient because the coverage of each test is limited, targeting on essential aspects. Um, Now we have another example, which is Ali. Now we have large scope testing. In large scope testing, each test covers an extensive range of code, providing broad system-wide coverage. However, this often leads to redundant coverage where many aspects are tested repeatedly. Coverage where many aspects are tested repeatedly and most results are not checked, which can create a false sense of security. While large scope tests may be easier to set up than mid-scope tests, since these tests depend on the whole system, issues may not be caught immediately. Now we have exploratory testing, which is a hands-on approach where developers and testers examine the software to understand how it behaves. Often in scenarios that are challenging to set up. This method is commonly used to gut check new code or verify that the existing code work as expected, especially in unique situations. The main tools of exploratory testing include application itself and REPL environments. REPL stands for Read Eval Print Loop. Uh, Exploratory testing is really useful for quick checks, early investigations, and one-time tasks. Now we have unit tests. Unit tests focus on small, specific parts of code, usually testing just one function or class at a time. They are designed to check visible behavior that we know the function or class should follow. Instead of watching every step in a process, it check the end result, which makes them easier to read and understand. While writing unit tests, it's okay to keep them simple and straightforward. It is better not to add extra logic and create new complexities in the test. This makes the test harder to read and understand. In contrast, a better example. Okay, so we can take an example. The better example keeps things simple and focuses on only one outcome. But on the other hand, a bad example include the test is complicated. It tries to check each part of the process, first generating a password, then attempting to create a new user entry, and finally handling an error if the username is already taken. Now, we have behavior driven development, BDD. It is a testing approach focused on user scenarios instead of testing each piece of code in detail. We look at the big picture of what a user would actually experience. BDD uses a format called average range act assert, which breaks down each test into three pieces. Given when okay then. And this format is easy to understand and help us create tests that are readable and self-explanatory. Also in BDD, it is good practice to write tests before we code uh, in the feature. Record the feature. Okay, this is an example. Let's go through this example using BDD to test a simple TV set. First, we set up the scene by saying, as a TV owner, I want to turn the TV on and off so I can uh, watch it when I want and save energy when I'm not using it. This is basically if you have learned about use cases, then you will see or use cases if I'm not wrong. So you have seen that we create small chits, and on that we write us like if we have an app we write that whether we have to write the use cases. Let's suppose we have a travel planning app and we are writing a use case which is related to actually a test case, and which test case is basically for the sign up. Then the the use case or the BDD example can be written as um, like as a user, and after that I will write I want to here we have written I want to be able to turn the TV on and off. So I will write in my sign up example that as a user I want to sign up to the page or sign into the page so that I can access my previous progress. Okay, so this is basically a use case and a test case example. Okay, we just skip it. Test doubles simulate real objects in tests to handle complex dependencies efficiently. Using real dependencies provide accurate. Sorry, just have to see. Okay, it is working. Yeah. So using real dependencies provides accurate results, but complicates testing while fakes, stubs, and mocks simplify tests, but risk inaccuracies if overused. Challenges include long test execution, reliance on specialty hardware, and setting up complex environments. Dependency injection improves testability by allowing controlled injection of dependencies, making tests more manageable and reliable. Okay, now we have these are basically integration types, integration testing. Integration testing, we combine the part of our programs. Like, okay, in unit testing, we see that we only test a class or an object, a class or like small portion of our app. But in integration testing, we combine um, unit testing. Like, okay, we combine the units, two or three, and then we test them. And then we add more two or three elements or units, and then we test them again. And then we add two or more, okay, one or two more, more units, and then we test the complete again. Okay, so if we have 10, okay, so if we have 100 units, then we will have to test, uh, in integration testing, we will have to test it 99 times. First time we take two, then we add one more unit, and then we add one more unit, and okay, so on, so far, so on. So it is really hectic as well, and it consumes a lot of time. Integration environments, here we have like feature flags, you can just read them. Here's engineering CI. Let me share you one thing. One minute. I'm just doing some. Okay. So now we will discuss about continuous integration, which is about build and test whole system regularly. We continuously add things, or matlab, we continuously add units, and then we test as well them. So continuous integration is mainly this thing. Okay, we have to continuously check, or even the thing that I discussed earlier, that in continuous integration, what we do, in previous slides we learned about integration testing. Yes, so the continuous integration means adding more units and then testing the whole system again. So this is all from this lecture. um, if you have any questions, you can ask in comment section. Thank you so much.